Hello, everyone, and welcome back to my class, Monica Maths classes. I hope you have understood the last topic, which we have done real numbers, which is divided into two parts, part one and part two. So, practice again if you have any other doubt. And today we will begin with the new topic, which is called polynomials, a very important one. But before we begin, I want all of you to subscribe the channel and also refer to your friends and relatives so that they can also solidify their concepts well. So before we begin with our journey, I again want all of you to enjoy it, okay? And you will understand it is linked with you. All the things are related to what you have done before. So let's begin with our today's class, polynomials. So polynomials means many, right? Whether you do in science or math, anywhere, it always means many. So we will begin with that, but it is related to algebra. So you must have your memories related to it. So what is a polynomial? It is simple and algebraic expression. So let's begin with the definition of it and recall it. A polynomial is defined as an expression which is composed of variables, constants, and also separated by mathematical operators, addition, subtraction, multiplication, and division. So a very important part is here is that you understand that how it looks like. Now the example which is given, I'll give you another a very easy one. Suppose if I say I'm writing here x plus 3, this is also an algebraic expression, this is also a polynomial. So here, if you see, x is called variable, okay? X is variable and 3 is a constant, and both these variable and constant is separated by an operator which is plus sign. It's an operation, plus sign. So it's an algebraic expression. It is a polynomial. So what is needed? Everything is there. So from here, you can define it. Now, if you see in the next one, they have given you more than that. Now, in algebra, there the exponent, if it is 1, it's hidden always. It's not mentioned. So if you see here, it's written as 1, but we don't write it in algebra. So it is x plus 3 and its power or exponent or degree is 1. So if you see, there are two terms, 1 and 2. There are two terms here. So it is called a binomial. There are two terms, remember, one term monomial, two terms binomial. Now let's see how many terms are there in this example. So you have one term, you have second term as 2y, then you have 7. So there are three terms. So ideally, it's a trinomial based on the number of terms. And then you have here as a quadratic polynomial. This is also called as a quadratic polynomial. Now I'll explain you why it is called as a quadratic polynomial. Quadratic polynomial, why? Because it has the exponent as 2. The highest power of the variable is 2. Now here are two variables, x square and y. These are two variables. This is coefficient. Now coefficient is that number which is attached with the variable before the variable. So you have 5 and here you have 2. So both are coefficients. So if I ask you what is the coefficient of y, it is 2. What is the coefficient of x square? It is 5. And 7 is a constant. Constant is a simple number. I hope you have understood from this, all of them, which one is a variable, which one is a constant, and which are the coefficients. So if I give you another, if I ask you another one, suppose if I say 2y plus 7x plus 3, a simple one. Okay, so this, first of all, say what are the variables y and x. What is the coefficient of y? 2. What is the coefficient of x? 7. Which is a constant? 3. What are the operations attached? Plus. How many terms are there? 1, 2, and 3. So it's a trinomial. The highest power of the variable, here it is 1. Okay, so it is a linear polynomial in two variables. That's how we say it. So let's now again recall based on the number of terms and based on the number of degrees, how you define that. What I'm saying it, how is it making sense? Okay, so let's move on. Now, based on the number of the terms. So ideally, we divide polynomials based on the number of terms. Okay. So if I say, and based on the number of degrees. So if I say, if I have one term means only one single, a number, or there is just one variable, like you have 4x cube, and this is also just one term, attached with it. A square b cube is just one term because a and b is multiplied together. So we see all these three as just one term, if you get this. So one term is called monomial. Mono means one. Bi means two, bicycle, binomial. Bi always means two. Okay. So now two terms. So you have 6x and 2 as two terms. So it comes under binomial. A b raised to the power 4 minus 5. So you have two terms again. So it is a binomial. Y plus 2f. Again, it's a binomial. Okay. So understand, two terms means binomial. Again, next is trinomial. Trinomial means you have three terms. 1, 2, and 3. It is three terms. Now let me give you an example. Suppose if I write x plus 2x plus 3, do you think you can consider this as a trinomial? No, not at all. You think that there are three terms? No. X and 2x is, they are like terms. You can write them together as 3x plus 3. And 3x plus 3 means you have only two terms in it. So this is a binomial. Okay? X, 3x plus 3. And x is one variable. So sometimes, in question, your examiner can ask you that they can write in this form and they can make you confused, but there's no confusion. Same like terms, same variable. You can add them together or you can simplify further, and then it is considered as just one term. So you have two terms in it. It comes in as a binomial. Then if you have more than three terms, we called it as a polynomial. Okay. So polynomial. I hope this is clear now. So polynomial means many. Poly always, wherever you read this, the word poly, it means many. So you have more than three. 1, 2, 3, 4. You have four terms. So we called it as a simple polynomial. In fact, again, I would say that polynomial is a big family name. So if anywhere somebody asks you as true or false, is trinomial a polynomial? Your answer should be yes, it is a polynomial. Okay. And polynomial, when it becomes more than three, we don't give a specific name to it, then it becomes a polynomial. Now let's move on to the next. Now, as you divide in the form of the number of terms, similarly, when you go in higher classes, like right now you are, so based on the number of degrees. Now, what are degrees? Degrees means the highest power of the variable. Now, check over here. First of all, you check in the first one, you have constant polynomial. Constant means a number. So there are no degrees attached. There is no variable. There is no degree. So the degree is 0. Now see the linear polynomial. When I say linear, you remember in the previous slide, I was explaining you that they are linear. So how do you say it? So x. What do you think x power is or degree is? It's 1, which is hidden. So that is why it is linear. 1 means linear, okay, in algebra. And here also 3 upon 4 x minus 1. So x minus 6. So here it's a linear polynomial because the degree of the variable is 1. The highest power of the variable is 1. Or you understand exponent. All are same thing. These are exponents. Okay. Now next, check the quadratic polynomial. Quadratic means when the highest power of the variable is 2. Now can you see x squared? Its exponent is 2. That's the highest power here. We don't count for x, which is 1. We will look for this. This is a quadratic polynomial. Even this is a quadratic polynomial because here y raised to the power 2. We are checking the degree of polynomial here. Okay. So this is a polynomial. Now next, cubic. Now the word cubic means the exponent or the degree of the variable should be 3. Now, can you see that? Simple, a 5x cube is written. It's a cubic polynomial because the highest power of the variable is 3. And for this one also, it's a cubic polynomial. So I hope this fundamental thing should be clear to you. Fundamental because always it should be clear in your mind when you start solving it with other topics also. When we say a cubic polynomial, a quadratic polynomial, you should understand, and it should be in your mind that the highest power of the variable is 2, then it's quadratic. If it is 3, it becomes cubic. So it becomes a little easier for you. I hope this is clear. Now let's move on to the next part of it, which is again, after that will take you to the exponent or something. The next part is the zero of a polynomial. Zero. Zero of a polynomial. Now, what does it mean? A polynomial and it's zero. Okay. First of all, let me solve it. Then it will make more sense to you. Okay. So here, find the value of px. P stands for polynomial at x. Can you see? There is a variable x over here. So p at x, polynomial at x. And at x is equal to -1. So we have to find out the value for this polynomial. So if I put the value for x as -1, so what will happen? So here I am going to write the value for x is -1. So let's see. It becomes -3 into -1 -4. So what could be when I solve it? -1 raised to the power 2. It becomes positive. -1 into -1. And minus it becomes plus, so it becomes 3 minus 4. And when I simplify further, 1 plus 3, 4. 4 minus 4 is 0. I got 0. Okay, so that means when I put the value for x as -1, I get 0. So that means -1 is the 0 of the polynomial. This means that -1 is the 0 of the polynomial. This is the value of the variable. When I put the value of the variable, I get 0 okay, 0 of the polynomial. This one, px at x -1. Now, similarly, suppose I got 0 when I put the value for x is -1. Are there any other values when I put the value for x something which gives me 0? Will you try it? Okay, so let me say if I put the value for this variable as 4, let's check. If I put the value for x as 4, what will happen? So in place of x, yeah, you need to put the value for x as 4 now. So x square means 4 square. Next, -3x, 3 into 4, -4. Now what will happen? 4 square means 4 into 4, 16, -12, 3 into 4 is 12, -4. What is 16 minus 12? 4. -4, what do you get? 0. That means when I put the value for x as 4, even then I get 0. That means this implies that 4 is also the 0 of the polynomial. It is the 0 of the polynomial, okay, which we have put right now. So understand, when you put the value of that variable as whatever, if it is given, and you get after solving as 0, then that value which you have put is the 0 of the polynomial. Okay? Is it making sense to all of you? I hope it is making sense that whatever value of the variable when you put, like here, when I put x as -1, after solving I get 0. 0 means yes, 0. Then it is the 0 of the 0 of that polynomial. And after whatever is given, I check it again with another value. When I put the value for this polynomial as 4, even then I'm getting 0. That means there are two zeros of this polynomial, -1 and 4. So if somebody asks you that, how many zeros are there? -1 and 4. These are the two zeros of this polynomial. And let me tell you, if you have a quadratic polynomial, did you recognize the highest here? The degree of this polynomial is 2. So it's a quadratic polynomial. So if you have a quadratic polynomial, you will have two zeros. If you have linear polynomial, you have 1 0. If you have cubic polynomial, you have 3 zeros. So understand this. In grade 9, I remember you all have calculated, find the zero of the linear polynomial, remember? So that how it looks like. Okay, so let me give you one example of it. I hope you all remember that linear polynomial looks like of this form, ax plus b, where the power of x is 1, we discussed just right now. And if I say that suppose your polynomial is given as px, because we are saying that there's a polynomial at x. So if I say 2x plus 3, and I ask you find the zero of the polynomial, how will you calculate the zero of the polynomial for this? So you will find the zero, you will put in place of this as 0 is equal to 2x plus 3. And then you will simplify it further. So it will be 2x is equal to minus 3. Transposition method, yeah? So x is equal to minus 3 upon 2. So that means if I put the value for x as minus 3 upon 2 in this polynomial, it becomes 0. So find the zero of the polynomial for linear polynomial you have done in grade 9. And this is the process. This is the way you all have done it. So in place of px, you write 0 and you get the value of for x. Yeah. So this is what you have done. And here, find the value of this at x is equal to minus 1. You put it yourself any other value and you get 0. So that's the thing. Okay. So now this topic, there are many things attached to it, but before we begin with this, this is something very easy, that what is the geometrical meaning of the zero of a polynomial? Because in algebra, geometry is also a very, an integral part of it. So once you've understood, you will understand very easily the later part of this chapter. So there is a graph given, and remember I said that what are linear polynomials when the degree of the variable is 1. So now consider first a linear polynomial ax plus b, where is a is not equal to 0. This a, which is attached with x, is a coefficient. So you don't have to make it 0, because if you make it 0, what will happen? 0 multiplied by x becomes 0. So there is no x then. Yeah. So a should necessarily not be equal to 0. So ax plus b. Now you have studied in class 9 that the graph of yx plus b is a straight line. I hope you remember that. It is always a straight line like that. For example, y is equal to 2x plus 3 is a straight line passing through 2 points. Okay, so here what are those 2 points passing through it? One is minus 2 and minus 1, and the other one is 2 comma 7. Can you see that? They have also marked it, this one, and they have marked it this one, minus 2 minus 1. Okay, so it is passed to these 2 points. So now I'll explain you, while seeing the graph, how will you understand how many zeros are there and why these zeros justify to that graph. So first of all, my question is, why are the zeros of a polynomial so important? Think. Why we are learning this? Why are the zeros of a polynomial so important? You all have calculated the zeros in grade 9. Again, you are calculating the value of the variable by putting some value. To answer this, first, we have to see the geometrical representations of linear and some quadratic polynomials. I'll show you how you're going to read it. And then you will understand the meaning of the zeros. Right? Now, do you remember that just now in the previous slide, I have shown you that x is equal to minus 3 by 2 for linear polynomial, yes? Now, we will see that is it making sense or not. Okay, so y is equal to 2x plus 3. Okay, now here, can you see, is it making sense to you that here this line intersects the x-axis between minus 1 and minus 2? Can you see that? All of you, please focus here. There are two lines, x-axis and y-axis. X-axis is your horizontal line and y-axis is your vertical line. And this line, which we are talking about, this is intersecting y and x. But look at x, okay? It is between minus 2 and minus 1. Okay, now where it is going, this one is actually on x-axis, so y is 0. I hope you understand coordinate geometry, how to coordinate, how to locate the coordinates and read it. So On x-axis, y is 0. So I'm talking about this point, and x coordinate is minus 3 upon 2. Minus 3 upon 2 because it is towards the left side. That's why it is minus. And minus 3 by 2 represents minus 1.5. Can you see between minus 1 and minus 2, it's exactly in the half? And that is what exactly this is also showing. X is minus 3 by 2. This is the zero of the polynomial. So here, understand in general, linear polynomial has exactly one zero, which is intersecting at exactly at one point on x-axis. So if it touches exactly at one point on x-axis, it has one zero. And you can read it also, it is this one, okay? Which wherever it intersects the x-axis. So it has 1 point. So the zero of this polynomial, 2x plus 3, is its x coordinate intersects the x-axis at this point. So this is the zero. You can read the zero as well. I hope I'm clear. So try to read now where the lines are touching the x-axis at how many points. And that will give you the answer. Those are the number of zeros. You don't have to calculate. You can calculate because you will calculate it, but reading it also is very important. Okay, now you tell me, this is a quadratic polynomial. Y is equal to x square minus 3x minus 4. It's a quadratic, right? Now, for quadratic, generally you get such kind of graph, and the formation of this graph is called a parabola. So sometimes it is downwards, sometimes it is upwards. So you will get this. But the point is, we are not looking at the shapes that how it is. We have to check that at how many points, it is touching the x-axis. I think this is my first point and this is my second point. Can you see that? So when you look for the quadratic polynomial, you can see on the graph that my graph is touching at -1 and 4 at 2 points. Can you remember this is the same polynomial I have taken? Can you see this? This is the same polynomial. X square minus 3x minus 4. At -1 it is coming 0 and at 4 also it is coming 0. We have proved it. Now you check on the graph also. It is checking. When you carefully look at it, it is exactly touching at 2 points. One at 4, which is positive, and one at -1. So it has two. Okay. So it has two zeros. -1 and 4 are two zeros of the polynomial. Okay. For this. And we have proved it just now. And that's the answer for it. So understand wherever you see the graph which is formed, at how many points it is intersecting the x-axis. That's your answer. You have proved it and you have seen it here in the graph as well. I think it is making sense to all of you now. Now, based on our observation, we have seen generally on this quadratic polynomial, we have three cases. When you see the case 1, now in case 1, I told you that you get a kind of graph like this. This is a parabola, this is upward and then downward. It is touching at 2 points. So A and A dash, these are the 2 points. So these are the two zeros. Here also these are the two zeros of this polynomial. Okay, so this is much easier because you have seen it. Now you have case 2. In case 2, sometimes what happens, it touches at exactly at 1 point, A and A over here. Do you know what does it mean? It means that your two coordinates, they are coinciding with each other. They have become coincident. So A and A dash, when you say A and A dash, here you have taken this 2 points. So they are actually coincide to become 1 point. They are coincide to become 1 point. So sometimes it happens. You get 2 points which are coinciding on each other. So it becomes 1 point. So even then you need to check that at how many points it's touching. It is touching at 1 point. So they are coinciding. Okay. Now next, the third case. Do you see anywhere these graph are touching? No. So that means here there is no zero. No zero in this case. No zero. When it is not touching, there are no zeros possible in it. Okay. So it depends on the touching and how many points it is intersecting on x-axis. I hope it's much easier and clear now. So let's understand now that how much your understanding is increased after seeing it. So let's take few graphs and understand. The first one, you have to tell me that find the number of zeros, okay? And just tell me why it is so. I hope you can give me the answer on this. If you are in my class, live class, this is much easier. Okay, no worries. So can you see this graph coming? It is exactly touching at 1 point. So how many zeros? It's only number of zero, one. 1 0 is possible in this case. Now next, into how many points it is touching? 2 zeros. 2 zeros in this case. Can you see how many points it is touching? 1, 2, and 3? Yes. So 3 zeros. Next, how many points it is touching? X-axis, it's only 1. So answer is 1. For this one, it is coinciding. Remember that second case which we were talking about. So it is touching at only 1. So this is also 1. How many points? 1, 2, 3, and 4. How many zeros are possible? 4. Yes. So you have seen it is much easier. So today we have done how to interpret from the graph how many zeros are possible. Also, you can, calculate how many, if the zero is justified or not when they give you the value. And you can calculate yourself what is the value of that variable I get 0. So many ways are possible. This is something very important all of you to understand. I hope that you have understood the importance of that, why zeros are so important. So children, I hope for today's class, you have understood the concept of the zeros of the polynomial. What are polynomials? So again, I will say practice, practice, and practice, which will make you perfect and permanent. And you will eventually become confident. So all of you, I wish a very happy learning and keep practicing. And by then, rise and shine, all of you, and see you soon in my next video of polynomials. Yeah. So bye then.